In this episode, we're going to do pre-assembly to check the clearances on our rotating assembly and also get the measurements we need to get our final machining work done so that we can get that compression level where we need it to get the best race engine we can out of what we've got. Now, before we get started on this, I'm going to put a disclaimer on the front of this video. This is a very expensive area that takes a long learning curve with lots of nuances and details and stuff that you have to gain over time and you pay for in blood, sweat, and tears. There's a reason that race engine builders charge a premium because this stuff is very difficult and it's very easy to make a costly mistake in it. All right, with that said, let's get busy. Here's what I've got. I got a 350. It's a one-piece rear main seal. It's been cut 60 over. I've got an ARP stud kit for the 2-bolt main on it. I've got ARP studs for the heads already. Then I've got an Eagle rotating assembly. I've got a 4340 crank. It's not their flyweight ultralight crank. This is like a 50-pound crank right here. I've got a 3.48-inch crank as far as the throw goes. And then I've got the ESP 6-inch bushed H-beam rods. I went with the Mal 5cc flat top pistons. Those have got the file fit rings. It's got the thin ring packs, the 1mm top and second ring that are going to be file fit. I went with the bow tie Vortex heads. I really went back and forth with this. I looked for the 200cc Iron Eagles. From my research, that would have been the best head if I could have found those in the 49cc because you could just get crazy compression ratios with those heads. Really just struggling to find them. Can get these brand new off the shelf. I went with the 185cc intake runner. I think you can get them in a 185 or like a 225. I went with the small ones because I'm in a restricted 2-barrel class, you know, with a gauge legal 4412 carburetor. So I want that velocity. I wanted that smaller runner right there. All right, these heads right here, brand new. Got them sitting over here. I'll show them a little later in this video. Y'all stick around. Elderbrock raised runner Super Victor intake. This head right here has got a raised runner, the top of the runner on the intake. It's higher up, and so there is an intake specifically that has that. I have a Super Victor for Vortex, and if the class rules allowed me to grind on the intake I already had, then it would work. There was enough meat there that I could have cut it away and blended that and made it work. But because I cannot grind on ports on the intake or on the heads, either one, then I had to just take and purchase this completely separate intake. That rotating assembly from Eagle also came with a King XP race bearings. These are really great race bearings. That's a tri-material bearing right there. Better clearance tolerances, better materials that the race bearings made out of than a stock bearing. So I do recommend these. Even when I haven't bought Eagle rotating assemblies in the past and I've been working with stock cast cranks and stuff, I still opted and bought separately these King XP bearings right here. These are good bearings. So that's my stuff so far. I want to show you, since we need to drop this crankshaft in and be able to rotate it and know it's exactly where it's supposed to be, now's the time where we get everything figured out and clearanced and we know it's right for the crankshaft in the mains. So first thing that I'm going to do here is I am going to switch out all of these main bolts for studs. And I've got an ARP, this is an ARP stud kit. There's a couple different kits based on which block you've got, 2-bolt or 4-bolt main. If this is a 4-bolt main, I probably wouldn't put the studs in, but on a 2-bolt main, I've built a couple of these engines, and I've done got where I stud them. Matter of fact, I stud my heads. It's not really necessary, but I mean, I like having the studs. If I need to pull a head off, put it back, I trust my studs for me to retorque, you know, over time, pull and put stuff on and stretch them right back. And I know with ARP studs that I can just take and measure the lengths on them and I can check them even as I use them through their life. And so I have a lot of confidence in them. So that's where like the use of my studs is coming from. Not necessarily that I'm turning out so much power that the stud is required. It's more of the quality control over the material used to make the stud. I trust it more than just a factory bolt from who knows where. That's what it's really all about with me using studs. All right, so that's number one. And then turn around, and I'm going to make sure that the back of it is clean. And we're going to drop it in. All right. So it's in there. And then I'm going to go through and do that the whole way. Each one of these, I'm going to make sure they're perfectly clean. That's perfectly clean. I'm going to number them to the main they're on, and then drop all of those in. And then I'm going to do the same thing. I'm going to number, make sure everything's clean, and put the tops in all the way down through there. Got everything snugged up, and here's what I'm going to do. I'm going to hit them in 3 rounds. 80 pounds is what they torque to. And I think what I'm going to do is I'm going to go 40, 60, 80 is what I'm going to do. I want to make a quick shout out here to David Cove of David Diesel Parts in Ripley, Tennessee. Me and David have been racing for years. I've mentioned him a couple times. He helps me to get a lot of parts that I'm looking for on my race car. And he can get Eagle stuff. And so I was talking to David and told him, I said, I think I'm ready to order my rotating assembly. He told me, he said, just go on Eagle's website, figure out what it is that you want, write down the part number for the rotating assembly that you're looking for, give me a call, I'll take care of it for you. And found what I was looking for, called him up, gave him the part number. 24 hours later, I had a rotating assembly that was balanced by Eagle, ready to go. So really appreciate that. I'm going to put his phone number right here. So if you're looking for an Eagle rotating assembly and you want to get one, drop shipped at your house, some kind of deal like that right there, give him a call. He can take care of you. And he also does, he keeps mini torque starters on the shelf for me. And like I said, all the electrical stuff, that you use for race cars. So I really appreciate it. He's been a great friend to me. We do business together because he can get that stuff and get it in the best quality. So shout out to David. Thank you, buddy. I appreciate it. Now, what we're going to do here, we're measuring for the difference between our main journal size on our crankshaft versus what the bearing clearance is. And so I've got 5 locations. We're just going to do the mains. We're not going to worry about our rod throws right now. We'll do those after, we get everything together. We're just going to do the mains. And so what I'm going to do is I am going to write down all of my measurements for the crankshaft itself. And then I will set my micrometer, and I will go and I will look to see how much clearance I am on each one of my bearings down through there to match that. So I'm going to get my measurements right quick here. And this is just an inexpensive, this is a Fowler. And so Fowler this is not your highest, best grade. I've got some Starrett stuff, and I've got some Mitoyo measuring devices. Fowler is more this is like a $50 micrometer right here, but it is to the 10,000, and that's important. When I say 10,000, that's the 4th decimal place out from 0 is when I'm talking about 10,000ths. And when you start talking about clearances for oil and stuff, you really need to get down to that level where that you can get the accuracy, because a lot of times 5 10,000ths is your leeway. More than that, and you have a problem. So, you do need to be down to that level, so just be aware. So what I'm going to do, I'm just going to go through here, and I'm going to get my average measurement for each one of these mains and write that down, and then I'll come back and we'll get out our bore gauge, and we'll see what the difference is across all of these mains to them. All right, so y'all check it out. So when I did this, I was within 1 10,000th. I'm pretty much on the money. I am 1 10,000th under perfectly standard, which is fine. What I really like and impressed with is that I've got very, very, very consistent from one end to the other, the exact same numbers all the way down through here. All right, so I'm going to set up my dial bore indicator here next. Let me show you how I'm going to do that. So I'm going to take what I did, I set my Fowler here to exactly this number, 2.4499. So I got it set, I locked it down on it. I'm going to throw it in the vise. Let me get a paper towel here. All right, show y'all how I do this. course, my dial indicator is the same way, measures to the 10,000ths. And I'm going to turn my dial up. And let me lock my dial indicator on here. Now I've got this set up to measure, 2.4 to 2.5 inch is what the pin and everything is set up for. Alright. Doesn't really matter. I'll show you how this works. Sorry, it's very touchy. But it doesn't really matter actually where the needle's at. Because what I'm going to do here is I'm going to drop it in here, and then I'm going to turn around and I'm going to figure out where to get around here where y'all can see and I can see both. That is a trick in and of itself. But anyway, so I'm going to rock back and forth and find that highest point. I'm off just a little. I was really close. I'm going to move to where the highest point becomes 0. This will make sense when I go to doing the mains. You'll see what we're doing. So what I'm doing is I'm making the 0 be what the crankshaft was. As I rock the needle over the middle of the flat plane on the micrometer, see how it's coming up towards 0 and then going away? Trying to get it just there. I think it needs to come back just a little bit. Let's see. Right. Yeah, I'm there. I'm there. Okay, I'm going to lock it down. All right, we're done with this. And we've got this to where now 0 on here represents exactly what the crankshaft was. I'm going to go through these one by one. I'm going to measure 2 measurements in an X across on a 45 each way and take the average of that. If I had a big difference between the two, when I say big difference, like if I had 5 10,000ths or more of difference between the two measurements, I for sure would be looking to see why that was. Take it back apart, measure the main again, make sure that I've got the concentricity, I can't even say that, y'all. But anyway, the roundness is the same both ways without the bearing in there. Measure the bearing again, make sure, find the reason for that. If something doesn't add up, you have to find the problem. You have to solve it no matter what. So just be aware of that. And so for me, if I had 2 or 3 10,000ths, that's fine. That's margin of my ability to measure and, the quality of my equipment. More than, 5 10,000ths, yeah, there's something there. I'm measuring accurate enough that there's something there that I need to deal with. Since we've got our bore gauge set to 0, all we have to do is take the measurement. It's going to be less than 0 because this is bigger than my crankshaft. And so we're going to sweep it around here and see what she comes to. And we're coming up to 77 from 0. So that would be, I'm going to write this down. This is on the first main. So 77 from 0, that would be a clearance that way of 0.0023. So 77 from 1 is 23. So 2 thousandths and 3 10,000ths, okay? And then I'm going to turn around and do it the other way. Get this up here. I'm just making sure I get nice, repeatable measurements. All right. And this way I'm getting 73. All right. So 73, you know, from 0.0027. All right. And so when I did my X pattern across, one was 2 3/10,000ths, one was 2 7/10,000ths. I'm fine with that. Like I said, kind of what I'm looking for, I would start looking if it was more than, you know, 5/10,000ths between the two. This is well within the accuracy of my ability to measure and stuff. I'm fine with this. What is that average? That average is 0.0025. So you can see here I've got my 4 main caps back off, got my bearing out of number 4 right here. I ran into a possible problem. Got to do some more measuring. I want to show you where I'm at. So you see I take my measurements down through here, and I came up right around 2.5 thousandths all the way down through here. So you see I'm 2.5, 2.3, 2.5, 2.7, and I was 1/1000th smaller than the crankshaft on this 4th when I measured it in the X. Now it had the 2.5 thousandths when I measured it straight up and down, and so I pulled everything back off here because I'm like, okay, I may have possibly not had the bearing setting in it correctly, a piece of debris, something going on, some residue or material in this main and I missed it, or on the back of the bearing itself. And so what I did was I just pulled these all out. It's hard to measure, you know, with my type measuring device, because I got some that stand up like this and they're better for this. This is just a general purpose, and so I have to get down. So I went ahead and pulled them all off where I can get to it easier. But what I'm doing here, I got some Scotch-Brite, and I'm just going to make sure that everything is clean, and I'm just going to clean this down, because it could possibly be something going on here. So I'm going to make sure that, you know, all my edges, I don't have anything where that I've got any rolled lip or anything possibly that's sticking up that I've missed on that. Same thing on the main here, you know, because the way these mains look, they've never been touched. They've had the bearing that was in them before. I can see the imprint from the bearing in the back side of the main, which is fine. You know, that tells me that, you know, I know that it was running with a crankshaft and the mains hadn't, you know, spun out of it or anything like that going on. But I'm going to take the Scotch-Brite right here. Got to be really careful, because you don't want to remove material. So I'm using green Scotch-Brite, but I'll tell y'all, you get aggressive with even green Scotch-Brite and you can start removing material and changing your dimensions. So you got to be very careful about that. I just want to make sure. So basically what I'm doing is I'm just doing enough here. It's starting to shine up a little bit. And you know, that imprint from the back of the other bearing is leaving. But really what I'm doing is just confirming that there's no residue, no type of any type of a material stuck to it that maybe I just don't realize. And I don't think that was it either. I'm going to spray all of this with like brake clean and take paper towels and clean it perfectly clean. Back of the bearing, same deal. I'm just going to take my thumb, make sure, and it could be the bearing. And I can tell you the next step we're going to go to. It could be that the bearing wasn't seated correctly. It wasn't sitting in there right. Possibly my little lineup tang right here was hung on the edge and kind of pinching it in. And I missed that. You gotta be, I mean, it's very tedious. So I'm just gonna make sure that everything is great. Back of this bearing is just whistling Dixie. Clean and polished up. All right, that one looks good. And then I'm going to bolt it right back up and check it again before I do anything else. The next thing I'm going to do after this is I'm going to start measuring and making comparisons, because I'm good, I'm bad. And so if it's not that I just didn't have this bearing sitting in here right, or it was some residue or something that I had missed and it was something else, well then at that point I'm going to start comparing. Like, so for example, put the bore gauge on and see, am I the exact same? Like, take this bearing out, and torque all of these down, and then is the round hole the same roundness and the same size main to main to main, like that right there, which very likely they are, and then turn around and take my micrometers and check my bearing thicknesses. And I would say that the next place, if this doesn't clean it up, it would probably, I'd go to bearing thickness, which is fine. It's just, you know, I would be, okay, I found it, I've got a problem with my production in this bearing, let's order another bearing and get something that matches up. But I think the bearing wasn't sitting in the cradle right. Anyway, I just want to show y'all, because that's the point. It's like you can't ignore things, and there it was. There was something right there. You know, so very tedious process. So I'm going to turn around, spray all of this down with brake clean, and then put this cap back together and see what it measures. We're torqued all back up. We left these out of the way where we can get to it easy. I'm just going to make a check here. Show y'all. Yes, I measured this before I turned the camera on, so I already know. But I'm going to show y'all. And so you see I am 72, 70, I'm in an angle. I think that's probably 71, which would be 2 thousandths and 9 10,000ths. All right, so I'm going to write that number down. 0.0029. And I'll tell y'all, I would expect this to be a little bit bigger, because I took that green, you know, Scotch-Brite, you know, and kind of polished and cleaned everything up. Got all the residues and everything. And so I gained a little bit. You know, if I did that on every one of these, I'd gain just a little bit. Now, is that where they're going to end up naturally anyway? You know, possibly. You know, when you get down to that level, you know, I can't tell you. I don't have the machinist experience and stuff. Again, I'm not a machinist. I just assemble my own engines. So I don't know if they naturally end up there. If you went back and measured later, you know, is there some settling that would go on, you know, or really does it matter, like, to take and clean and polish all of those? So that's just exactly what I was looking for. You know, they're all, you know, pretty well uniform, right around that 2.5 thousandths, a little more than 2.5 thousandths. Race engine wise, I would be concerned if any of these were under 2. And I would be concerned if these were, if they were all a little bit over 3, it would probably be okay, especially running like 50 weight oil. If they were all up at like 3.5, you know, yeah. You know, maybe we're looking at a +1 bearing. If they were at like 3.5 thousandths, I would probably say, yeah, maybe I need to tighten that down by 1 thousandths and get back down into this sweet spot right here. You know, if they're under 2, I definitely would be looking to do some polishing or something to see if I couldn't get it back up above 2 with a race bearing. If it was on a crank on the street, on a cast crank, you know, if it was at, you know, if I was getting like between 1.5 and 2, I'd probably let it go. On a race engine, I don't think I'd let anything go that was under 2 thousandths. I use assembly lube very sparingly. There's no telling the engines that I have used assembled with it. I use it very sparingly. I like to use engine oil, and I just use this like basically just a film on my bearings. It's just my preference. I don't know, but in my mind, this stuff is thick, and I don't want it blocking an oil passage anywhere, and it wouldn't perfectly block it or anything, but like on initial startup, is it going to make the oil slow to flow somewhere initially until it pushes it out of the way or something? I don't know. It's just my personal thoughts on it. So I've always, you know, like just a very little bit, and then, you know, a thin film. You know, no globs or anything, just a thin film. I don't want any like stuck in any oil passages, holes, or when you drop a crankshaft in, it pushes it all into the oil passage hole. Just my preference here, but that's how I do it. I'm gonna rub it on all my bearing surfaces, and then I'll just take my hand with the coating on it and just rub over the crankshaft on all the mains and everything and drop it in. So the way I'm doing this is one by one going through each oil passage and making sure that they are clean, clean, clean. Make sure everything is perfectly clean, which this crankshaft is. I mean, it's perfect. But This is where I'm at. I've been working my way down, but I go one by one through each one, make sure each one's perfectly clean. I'm telling you, the life of a race engine is absolutely the cleanliness of it. So like I just did my port going down into my main journal, came out right there. Then the next port goes through here, so I just keep going down. Make sure I don't miss any of them. Wiping them off as I go. I'm fixing to drop this bad boy in here. I'll tell you, you see that tape I've got on those studs? Let me tell you something. Threads on a bolt, a stud or anything, are just tool steel as far as cutting through. If you bump those threads, it's gonna cut right into a surface. All right, y'all, check it out. First 4 mains are in, completely torqued up, crankshaft's totally free, everything's great. You see the rear main off? We're working on thrust bearing here. And I wanna show you. All right, on the bottom here, you see I've got a dial indicator here on the end of the snout of the crank, and I'm just gonna move it forward all the way. I'm just using a small screwdriver. I don't wanna get crazy with it or anything. Don't wanna spring stuff, but you know, 7 thousandths back to 0. So 7 thousandths on this upper main half thrust bearing. So those are those, you can see it on my cap here. That's that side part right there. I've got 7 thousandths. That's great. Small block Chevy, you know, 5 to 10 thousandths. You know, ideally with me, if I'm at 5, 6, 7, I'm happy. If I was all the way out at 10, if the engine was going to be used with a big heavy clutch, something that's going to really push on the crankshaft, I don't know that I would want to be all the way out at 10 to start with. It wouldn't be the end of the world if it was. Don't get me wrong. Everything is designed to float. My rods themselves, you know, they're actually floating on the wrist pins with the crankshaft. So it's designed to be able to have that movement in there. And newer vehicles, newer engines and stuff, not race engines, they don't have as much thrust in them because they have sensors on the crankshaft and stuff that they want to keep in an exact position, whereas this engine is designed to have a little bit of movement in it. So 5 to 10 thousandths, I really like 5, 6, 7, totally happy with that. I would not replace the crank if it was at 10. I would order some more, another set of rear mains to see if I could get it a little bit tighter. But anyway, so yeah, there we are. Now, the reason I did that, yeah, I was going somewhere with this. I want to show y'all. So I'm going to drop in my cap. I'm not really worried about torquing this down. I'm going to snug it up. I'm going to take a dead blow hammer and I'm going to bump it end to end. And the reason I'm going to do that is I want to make sure that it's not because I've got a flange that's not seated, okay, on the sides of the bearing. So I'm going to give it a bump. And give it a bump. I'm going to put it back. Make sure that it wasn't because that I didn't have a flange seated, because that can happen. And that, if that fooled you and you clearance that bearing because of that, then the life, as the engine's running, it's going to take that slack up, and then you're going to have a lot more. Give it a little bit of a pull now, where it won't move on me. So that's probably like 20 or 25 foot-pounds is all I put on that. All right, get my screwdriver here, and go all the way to the rear, and sitting on 0, I'm gonna go forward, and it might be varying 1/1000th, okay? Literally 1/1000th. And so all of that is in this cap thrust bearing, and I have not got the thrust bearing clearance that I need in my cap half of the shell. I have got to fix that. I've got to put 5 thousandths into that thrust bearing. It's not the end of the world, and this is something that you normally have to do, you know, if you're under. It's a pretty normal process here. So like in this case, this is not something you would not like say, oh, I need to go buy a new thrust bearing, you know, because, you know, I don't have enough clearance. No, you put it in there. You see how we've got these little lands, ridges and stuff? Well, this surface will have a variation. It'll have like ridges in it. So you need to get a couple of measurements around it across the flat. So like I'm gonna take my calipers, and I'm not taking micrometers because we're in thousandths, not in 10 thousandths. You know, and I'm gonna measure this around and make sure that I've got the common measurement all the way around. And then I'm gonna turn around, and after I get this measurement, I'm gonna take a piece of plexiglass here. I've got some 800 grit sandpaper, and I've got some 2000 and some oil. And I'm gonna lap it, and I'm gonna measure, and I'm gonna lap, and I'm gonna measure, and I'm probably gonna stop when I hit 4 thousandths instead of going all the way to 5. I'm probably gonna stop at 4, drop it in, see where I'm at. And I am absolutely gonna put this in a parts washer and make sure it is perfectly clean, because the material that's created in this lapping process is extremely abrasive. You don't want that anywhere near your engine at all. So, put some oil on here. 5, 6, 7, 8, 9, 10. 10 like that. Turn it around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 10 that way. All right, that was on that side. Now I'm going on this side. So you see what I'm doing here? Like sharpening a knife. 3, 4. All right, so I'm going to continue this process till I get a good clean 4 thousandths of clearance added to it. Then I'm going to polish it out with this 2 thousandths, doing the same process. I say polish, just I'm saying that because this is much, much finer. Wash everything in parts washer, perfectly clean, none of these abrasives. Put it back together, and then we'll come back and see where we're at. At this point, I think I've got more bearing material on the sandpaper and in the parts washer now than I do left on the actual thrust journal. But I'm there, finally got this thing where I want it. And I've got 5 thousandths in it now. Now there was 7 in the bottom. I finally got the top cut back to where that now I've got 5. And we're quitting right there. Lord knows I have cut on that thrust bearing to get that. But we've got it. So I am happy with it. All right, I went ahead and got my rod journal sizes for 1, 2, 3, 4, 5, 6, and 7, 8 across here. And I just took, and what I did, you know, opposite points to each other. And I did them on both sides, which, I mean, the crankshaft's perfect. Don't get me wrong. It's like, you know, I went through and I measured it. Especially when you know, if you got unknowns and stuff, don't ever skip any step. Don't ever say, wow, this thing's perfect, and then just not do the last one or whatever. Do all the steps. But I went ahead and I wrote down, and it was to the 10,000th. It was, you know, 21,000 all the way through. I couldn't even get 1 10,000th variation in it. I got 1 10,000th, you know, when I was doing the mains. I couldn't even get that when I was doing the rods, 2100 there. All right, but I'm not going to do all 8 rods right now because this is just pre-assembly. I'm just going to use 1 rod and piston assembly on the 4 corners. I'm not going to put any rings on the piston. You know, main thing I was doing is I wanted to check those, make sure that my crank was sized correctly, and then I put it together and torqued it down and just checked to make sure that I had oil clearance here. I did. I had about a little over 2, close to 2.5 thousandths size as far as oil clearance right here. So no problems there because we're going to bolt it onto the 4 corners. And since it's all coming back apart and going back to the machine shop for final machining, I'm not going to go ahead and do all 8 rods and number everything out and, you know, do all my clearances on all of them, because then I just got to keep up with all of that. And I got to number everything, and then I got to make sure that I get it back in the right spot. So, not even going to bother with that at this point. I think that would be a lot of wasted effort right now. So, I just put a clip in one side here of the piston because it's not going anywhere. Little bit of lube on everything. And I am just going to stick this all together. It literally really doesn't matter for this. These are 2 eyebrow. Of course, these are 2 eyebrow pistons, so it really matters which piston goes which way on orientation. But for us to just get this deck height measurement, nope, doesn't matter. We're not doing that part of it. So just keep in mind, this is not necessarily going, you know, where we're putting it on these 4 corners. Not for this. Not for this. So everything lubed up, good to go. I'll go ahead and just grease over these journals here, and we will do these 4 corners. You got a flat edge on your rods that go towards each other where the 2 overlap, and then you've got a chamfered edge right here that's got a lip on it that is designed for that clearance on that crankshaft on that edge right there. So rods only go one way. Don't have to put bolt covers or anything on it because these have just got cap bolts on them. So not a big deal there. Let's see if I can get this to be super careful. Do not scratch your crankshaft. It's really easy to scratch a crankshaft, y'all. Super easy. It's also really easy to have a piston and rod fall right back out of the hole and hit the ground. And when the head of that piston hits the concrete, it's going to break a ringland. And if it doesn't break a ringland, assume it broke the ringland. You just can't see it. You're going to have to replace it. Don't let a piston hit the floor. Basically, if you let a piston hit the concrete floor, it's broke. Because anywhere it lands, I mean, it's either going to land on the head of the piston and could fracture your top of your piston, your ringland there, or it's going to land on, you know, the skirt. And so you think about it, I mean, anywhere it is, you've had a trauma on something that, you know, when it fails later, it's going to cost you. So don't let it hit the floor. That's the listen to the story. All right, I got my catnip up, so it can't fall out now. Turn it back just a little bit. Of course, there's no rings. I'm pushed up. I've already had this rod together before. My bearings are right. My rod's put together right. I'm going to take my rubber mallet here and make sure that's seated in there good. I'm going to pull it up. But I don't want it to be cocked over one way. You've got an alignment sleeve on these. Your factory rods don't have that, but these do. So I want to make sure that it's lined up, and it is. And now I'll pull it up here. Of course, these are ARP 8740 7/16 bolts. So they torque up to like 63 foot-pounds. And that's with ARP lube and everything. I'm not doing bolt stretch. And if you were really doing it the right way, like really precision work, you would work off bolt stretch. If I built engines for a living and everything, and I was building for other people, I would probably work just off bolt stretch, because that would be my best way of sleeping at night, knowing that I haven't done anything or missed anything, you know, where I have an engine come apart. It's my fault. Bolt stretch is the best way to do it. But I'm working with new ARP stuff, and I'm using their lube, and I'm going by their recommendations, and I have a lot of faith in ARP. And anyway, okay, so we got that one in. We're gonna turn her over, show you how this works. All right, so we're turned up here. Get you up flat. Here we go. All right, got a couple bolts that I throwed in here. I'm gonna put a straight edge across. I'm gonna do this outside edge right here, and I'm just using the bolts, that way my hands are free. I'll hold my straight edge. Okay, So now I know where 0 is on this deck currently. So I throw my magnetic base up here with my depth gauge. That's just so real quick without me having to put a degree wheel or anything. I'm just turning it by hand and I'm finding that true top dead center. That right there. Okay, highest point. And then I've got some feeler gauges. So I've got a 25,000, 24, 23, 22, and I'm going to take my finger and I'm going to press down. All right, I'm going to press down right here while I take a feeler gauge and check this back. Now, why am I pressing down? Well, I'm pressing down because the piston can rock within the cylinder, because like in this buildup I have 0.04 of clearance between the size of the piston and the size of the cylinder, and I want to make sure that I'm representing the closest that an edge can get to the head. So I'm going to press down on one side and that's going to rise up on the back, you know, make sure that I'm on top dead center, of course, which is right there. I press down with my finger here, so now I know I've got that tightest point on the back right here that represents just how high the edge of that piston possibly can get. It will be the same on either side. And then I'll turn around and I'll take some feeler gauges and see what that is. All right, so there's a 24. A 24 barely goes. That may be, I may have hit it right then. Here's a 25. 25 doesn't go. 25 doesn't go. So it's a 24, and that's what it is, okay? So, 24 thousandths represents what I need this corner of the block cut to. All right, so I'm just going to write it on the block, 0.024 inches. I'm going to turn around, and I'm going to repeat this on every corner. And then this block is going back to my machinist. Hopefully he can hook me up and get this deck down, and then she's gonna be ready to go. I wanted to show you one other thing. Hang on, y'all. All right, so I got my bow tie vortex here. Of course, these are the 185cc intake chambers, so they call these the small runner ones. I'm waiting on the bow tie intake for these to come in. I do want to get these cut. I'm planning on taking 40 thousandths off of these. These are advertised that you can take 40 off of them from the factory right off the bat. And they're like 66cc stock. So if I can take 40 off and get these things down to like 60 cc's, I'm going to do that for sure. So I'm going to take 40 off here. I'll have to take about 40 off of the face. It's not quite 1-to-1, but you know, it's close. It's real close to like whatever you take off the face when you're flat milling, you take off the intake. That's because the engine sits on a V. So as you go down, it gets closer. And if you don't take it off of the intake side, that'll make your intake rise up and your runners won't line up anymore. I'm going to go ahead and get this machine work done. I'll have to do the heads later because I want to mock it up with my intake, make sure I don't have any problems with getting that 40 and my intake ports still matching up and stuff. It's the only reason I'm going to hold up on having these cut yet, but I am going to get them cut. I don't know whether or not I'll have that in a video. It might not work out well for me there because we'd like to get some racing done too. I need to get this engine put together, but we want to get some races in as well. And racing and engine building at the same time has been super expensive. It slowed me way down. You don't see a lot of videos coming out right now. Well, that's why, because there's only so much money to go around. I would not be able to get this put together if it was not for my sponsors on the channel. You know, I have got several of y'all, you know, that are putting your faith and support in me at $5 a month. I've got a few of y'all, like the Live and Goods, you know, that are giving me $50 a month. And I've just been banking that money and everything, and that's how I'm doing this right here. I just make no bones about it. Y'all know I'm an open book. That's how I'm putting this engine together. That lets you know how much I appreciate it. If you want to look into sponsoring Dirt Race Life, I'll put the links on the channel. I'll put them right up here as well. Makes a huge difference for us. Thank you. Could not do this otherwise. Really means a lot to me. With that said, if you aren't subscribed, folks, subscribe. It's good stuff. See you next time.